Hey, listeners, before we get into this episode, I have some fantastic news. My new book, Developing Mathematical Reasoning, Avoiding the Trap of Algorithms, is coming out, and we are having a book launch webinar to celebrate. This book spans from kindergarten to 12th grade, explaining in detail how algorithms trap students and what we should be teaching instead.
Join us at this free book launch webinar and you'll learn what the traps of algorithms are, how to avoid them, and so much more. You don't want to miss it.
We'll go live on March 18th, 7 p.m. Central. Grab your spot at mathisfigureoutable.com/book-launch.
That's www.mathisfigureoutable.com/book-launch. We hope to see you there.
Hey, fellow mathers, welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
So let's get at it. We know that algorithms are amazing historic achievements, but they're not good teaching tools because mimicking step-by-step procedures can actually trap students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
Oh, so let's get it to it, Kimberly. How are you today?
I'm good. You've been traveling, and
Oof,
I
yes.
mean, tons and tons and tons of traveling. And you sent me a text and said, "Hey, I want to tell you about Sandra," and that was the entire text. I'll tell you about Sandra and a quote. So here we are, me asking.
Bam. So when I was in northern Alberta, I had a fantastic time traveling around the North Pole. I kind of was chuckling a little bit. Met some amazing people, had a really, really good time. Spent a lot of time in cars. They drive a lot out there. Sandra said, "Hey, let Kim know. One of the things I really appreciate about the podcast is that you guys don't agree on everything. And you kind of... that you kind of beat out your disagreements for everybody to hear." And I smiled at her and I said, "Yeah, I really love that most of the time."
I mean, you know what I find interesting is we agree on the big important things.
Fundamental, underlying. Yeah, absolutely.
And I think maybe because we kind of like melded and molded and that kind of stuff over time. But yeah, there are definitely things that we see differently. And, I don't know if it's because we have different teaching experiences.
Man, we definitely had different growing up experiences. We were in different places. We kind of went different directions. And I think I have some holdovers sometimes of some things that I did that I haven't thought through that I'll bring up and you'll go, do you really think that? And then I'll have to actually think about it. And there's plenty of times where I'm like, maybe not. Yeah, let me rethink that.
Yeah. And I also taught far younger students.
Yeah.
So, I think that just like more elementary, like you help me consider long-term effect. And I think, when we talk really young students, then I can share experiences. But anyway,
Absolutely.
Well, I'm glad Sandra loves our disagreements.
We'll try to keep that going. Yeah.
Yeah.
All
well,
right,
so you've been traveling a ton, but we've also been super busy. I mean,
getting a lot of stuff done.
We've
been working hard.
Yeah. And lots of good content, books. We just had the launch of The Trap of Algorithms. That's really exciting.
So exciting. So if you haven't heard of it yet, Developing Mathematical Reasoning, Avoiding the Trap of Algorithms is out and on the Amazon bestseller list.
Woo!
So super exciting within not even a whole week of being out for sale. Amazon has us as a bestseller. We have a little flag and everything that says bestseller. Cool. It was bestseller in the specific category of secondary education at one point. And then another one, now I can't remember what the other one was. Anyway, so fantastic. We're super excited that that's going well. We've had a blast launching that. If you haven't checked it out yet, it's your new book study book. We're very excited. Cool. And like you said, getting lots done.
Yeah. I really, really love our Journey members. I know you do too. And we actually...
that's our coaching group. Yeah. Coaching. Uh-huh.
So we recently, like in the last month or so, did this event with Journey, and we thought that we would bring it to the world. So we spent some time with Journey or talking about sequences
Yeah, sequences of
because,
tasks
yeah,
and
sequences are
ideas.
important.
Uh-huh.
So we thought we would do a couple of episodes for you, listeners, about sequences of tasks.
Yeah, that went so well, and everybody was really excited about it. We'll bring the parts of it that make sense to a podcast.
Yeah.
So I also want to circle back to something. A few weeks ago, I was on the podcast Math on the Rocks with the fantastic Dwayne Haybaker and Cole Sampson, and Kyle Aiken was there as well. I think it's just Dwayne and Cole that actually usually run Math on the Rocks. And I had a great time on that podcast. And after I did some work with them, one of the things that Dwayne said has just really been resonating with me, and I've been thinking about. He said, "So you've identified like a small set of major strategies." He's like, "Major? I'm really thinking about that. Like, what do you mean major strategies?" And we sort
Mhm.
of talked about the fact that we really believe that there are these major relationships that if we can build in kids' brains, they lead to major strategies so that kids can solve any problem that's reasonable to solve without a calculator.
Yeah.
Which then means we don't need a general solution that can solve any problem that's reasonable to solve without a calculator, because we have these few major strategies. And the great news is that if we build those few major strategies, we've also built the math. Like
Mhm.
they now have these major relationships, the literal mathematical connections in their brains, the neural connections. So super important, kind of an interesting thing that I'll just say again, there are major strategies, and they're right that I've spent a lot of time talking about problem strings, in part because we get a big bang for our buck
Mhm.
towards getting those major strategies built. We can do a lot of mathing in a short period of time. And if you've been listening to the podcast at all, you know that we often do problem strings on the podcast, because it's a fantastic way of really helping build those major relationships that lead to those major strategies.
Yeah.
But you just mentioned sequencing.
Yeah.
There are other tasks that so if you were in my university class, or when Kim was in the classroom, or if we go into classrooms, we don't just do or promote just doing problem strings. There are other tasks.
Yeah. I'm glad you said that because I think it can be misunderstood that
Mhm.
problem strings are the thing. That's the only thing. And so, yeah, absolutely. We believe very strongly in really rich investigations, kind of like a messy, lob it out, get kids involved and talking with each other and tinkering. Those investigations to bring out big ideas are super important. We
Mhm.
also love games, and kids reinforce things that they're learning, gives us an opportunity as teachers to circulate, to see what kids are saying and doing. You just get a different feel when kids are playing games.
It's a brain change up. It's a different kind of brain activity. Yep.
Yeah.
Yep.
There are also so many other good routines. Too many to name, but other really good routines that you can do in classrooms to have a little bit of a difference. Problem strings are our favorite. We've done some episodes on other routines, but just to reinforce and come at relationships in a slightly different way. We also, feel strongly about kids having opportunity to demonstrate their understanding. We're not adverse to paper pencil um, type of work.
Mhm. Mhm.
So there's lots of pieces, but if you listen to episodes and you think it's just problem strings, this episode is for you because we're going to talk about kind of how to put some of these things together.
Yeah, how do we sort of sequence
Yeah.
parts of that? So, one of the things we do in our coaching group that we call Journey, is that we talk about sequencing tasks. You might hear me in a presentation or work with me in a workshop where I'll talk about a part sequence. How do I say that? Partial? That's
Uh-huh.
the word I'm looking for. A partial sequence of tasks, but we've also created entire units
Mhm.
sequences. Those are in our Building Powerful Mathematics workshops. So some of the parts of those are that include kind of what Kim just mentioned, more open stuff, and then some smudgy curated number kinds of tasks where we analyze student strategies with some parts missing in them. And what we also need to really connect operations. And like you said, we think that there should be some practice involved, but how do you practice? Does that look like 1 through 29 odd, or are there better ways of practicing? So let's dive into, I just mentioned kind of a lot of things. Let's sort of dive into some of that.
Yeah. So can we focus today on kind of some foundational stuff for young learners?
That sounds great. Yes.
Okay, so let's talk foundation for a second, because when we talk about the foundations of young addition, a lot of people will think you start by having students learn and memorize facts. Like that's the
Yep.
starting point, right? You got to know the facts first, and then you can
Then you
move
could do real
into
math.
algorithms. Yeah,
Yeah. Yeah.
because and if you are algorithm focused, it might be true that you need kids to know single digit facts first before they can do any larger problems. But
Well, sorry, I'm going to interrupt you. If you're algorithm focused, it's not might be true. It is true. Like if you, are we going to disagree here?
no, 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 go ahead.
If a teacher's goal is to get kids to correctly repeat steps of an algorithm, then you've got to have kids have those facts rote memorized so that they can, because or it will be drudgery, right? They'll be counting and doing
Yeah, that's what I was going to say. Is,
over and over. They're going to be doing those single digit facts. Yeah,
yeah,
sorry.
yeah. There's some very traditional teachers who think they want kids to memorize facts, but they're still going to progress them through. They just will leave them counting on their fingers. So anyway, even in any case, you're going to start with single digit facts. But we say there are foundational relationships that lead to major strategies. And one of the really important relationships that we think is important is 10.
So for, again,
Things.
for young learners, yep, 10. Yep,
Yeah,
absolutely.
ways to mess with 10. And we uh, I was going to say what we believe about facts, but I'm going to hang on to that for just a second. But we
Okay.
believe that 10ness is a really important thing.
So that's one of maybe the common threads that if we think about sequencing tasks, we would make sure that combinations of 10 and how you
Mhm.
think about teens compared to 10 and how
Mhm.
numbers relate to 5 and 10, that we would have a common theme all about 10,
Yeah.
that could sort of run through a series of tasks.
Yeah, I'm going to add to that adding 10 to a single digit, or
Nice.
adding single digit plus 10. So there's so much about 10 that we would want. We also think a really important thing to work with is doubles.
Yep. Yeah,
Because then you could do so much off of those doubles.
absolutely. Agreed.
We also think that helping students understand deeply the commutative property
Mm-hmm.
is really
Mm-hmm.
important. Not just if 3 + 4 = 4 + 3 kids, like
Or
really.
call it here, memorize your turnaround facts.
Yeah.
Yeah.
So
Mm-hmm.
really understanding why and how the commutative property is at work. We
Feeling
also,
it.
yeah, we also think a really important relationship is the idea of adjusting.
Oh yeah.
So, like a little more than something, a little bit less than something, and why that can be true. So, those are major relationships and understandings we think are important foundationally for young learners.
Yeah, and there's some major strategies that come out of really messing with these young relations, or these early, maybe I'll say early, not young, or early relationships that we need. And it's not even like 6, it's just 3. There's 3 major relationships that cover all of the addition and subtraction strategies. So if we're really focusing on major strategies, we would say there's 6 strategies. There's 3 for addition, 3 for subtraction, but there's just really 3 major relationships that
Mhm.
feed into those strategies. So it's not about memorizing 6 strategies, it's really developing 3 major relationships, and bam, we've got kids reasoning toward the end of having single digit facts at their fingertips, and
Mhm.
so much more.
Yeah.
Yeah.
And so these relationships that you're talking about, if you were to say a list of 3 addition and 3 subtraction, it can feel like, oh wow, having
So
kids
much.
work with these 6, there's so many. But if you can step outside of like the name, or step outside of the details because it's addition or subtraction, if you can see the big picture, the properties at work, then you can see how they're all connected. And I think that's really important for us as teachers to say, how are these things connected, and what relationships am I building so that they can do some of the same work in addition and subtraction? It doesn't feel so disconnected.
Yeah, so maybe I'll just say them again. Like it's really all about partners of 10.
Mm-hmm.
So getting to 10 in some way and using that, or
Mm-hmm.
adjusting a little bit. So doing a little too much and adjusting back, or doing not quite enough and adjusting
Mhm.
up. And then using doubles,
Yeah.
like being able to really own doubles, and then kind of doing that adjusting back and forth off of those.
Yeah.
Yeah.
So let's talk for a little bit about these sequences. So there's kind of some categories that we think about. So
Hmm.
in sequencing, we think about bits that are kind of messy.
Yeah.
There's some messy work to be done, and then we also think of some bits that are strategy focused, and maybe that's where people hear a lot about problem strings, but
Hmm.
in
Hmm.
general, focusing on strategy. But then there's also this bit about practice in some way,
Yeah, those are some nice categories. And to be clear, when we say messy, we don't mean that the classroom's unstructured and kids
right?
don't know what to do, and that it's messy in that we send them off. Hey, go discover math. Hope you figure it out. Come back. I know I could tell you, but I'm going to be mean and just make you go find it on your own. We don't mean that at all.
Yeah, right.
We do mean that the problems the kids are messing with
Yeah,
are a bit more open, a bit more maybe open ended, but for sure open middled.
yeah,
And there's some grappling to do for kids. It's going to take them a little bit longer to dive in and like really figure out what the questions. Not be unclear what the question's asking, but really to
yeah.
dive in to understand the relationships that are happening. Go ahead.
Yeah, and it's messy in the sense that there are ways to go about that work that is not just one way. And there are several possibilities that are available to them. It's not messy like let me send you away for 45 minutes and hope you figure something out and then I'm going to call it done. It's so much more relational as the teachers working with kids and circulating and seeing what's happening and nudging. So it's not at all what sometimes people think. It's like I'm going to send these kids away and they're going to do it and hopefully they discover it on their own.
Yeah, not that at all.
Right.
Let's maybe give an example so we
Sure.
can be a little more clear. So could we take young learners and say to them, "Hey, I've got 10 ice creams. Some are vanilla, some are strawberry. How many vanilla, how many strawberry?"
Hmm.
And then let these young learners start thinking about that. We could even give them, like two colors, where I have white on one side and red on the other side, and we could, like, here, show me an example of 10 ice
Hmm.
creams where some are vanilla and some strawberry. Show me another example, and then I could walk around. I could say, can you come up with another one? And then as I'm walking around, and some kids got a bunch of them, then I'm like, do you have them all? Do you have all the possible combinations? So there's like it's messy in that way. It's open. The kids could say, "Well, I don't like strawberry. I'm going to have all vanilla," and then I could say, "Well, are there other possibilities?" And then really to keep kids challenged, then I'm not going to probably ask all kids right off the bat. Some kids are really still fussing with how do I record my. I now have the counters, so I've got 9 red up and 1 white up. But now I need to record that as 9 plus 1 equals 10, and the teacher's circulating and helping kids record what they've got. And then if kids got a bunch recorded, now I'm asking that kid, how do you know if you have them all? And the kid starts thinking about being, what's the word I want? Help me. If I'm trying to know if
Like
I
an
have them all,
organized?
yeah,
Yeah.
like I'm trying to organize and find a pattern so I can be, there's a S word, trying to be,
Structure.
yeah, keep going. Um,
Systematic.
that's the word I wanted. Well done,
Read
Kim.
your mind.
Yeah, yeah, nicely done. Can I be systematic about how, and we're not going to force kids to be systematic, but boy, we're nudging that way. That's
Yeah.
good mathematical behavior. So that's an example of something that we might do. And then we might follow that where now that we've kind of organized that a little bit, could we organize it in a 10 frame? And then that would help us kind of look at, do we have them all? And the 10 frames are great because they build off the 5 and the 10 structure. And so we can also look at equivalencies, like all of these combinations gave us 10 ice creams. We can also look at connecting addition and subtraction. Well, if you had 6 vanillas and 10 total, how many
Hmm.
strawberry do you have? And we could connect that with a missing add-in problem, but also with subtraction. We could also do some messier things to build an open number line by looking at some kind of tasks that could help kids think about measuring something. Like, for example, I know one task that we've written is if we have a kid doing a sack race, and we talk about, well, if this kid did 4 hops and their partner then started and did 6 hops, where did the partner end? Well, they ended 8 hops later. And notice that we've got kind of this hop thing where it's a span I'm sort of spanning this distance, and we could kind of connect that to an open number line. So those are all examples of things that are a little bit messier. I don't know if I have another word, where the kids are kind of investigating and we're really building foundational kind of ideas. But let's be clear, we're not cinching a lot there, and that's okay. There's a place for this messier stuff, but we have to also include more cinching kinds of things. So that was kind of your second, or do you want to say something before I go into the second category?
No, I was going to say just that in these kind of messier, like kids messing situations, lots of different ideas can come out. So and that way you're tinkering with big ideas of mathematics. So when you were
Absolutely.
talking about like the sack race type idea, you could also bring out if the first kid did 4 and the second kid did 6, you would be at 10. But what if the partners switched and the first guy went 6 and the second girl went 4?
Yeah.
Then you're talking about the commutative property. So lots of different ideas can come out in the same investigation, and then you get to tinker with what do you want to work with students on
First, because then you're going to want to eventually work on all of that, right? Yeah. Nice. So one of the other categories you talked about was being more focused, because we've just now been messy and got all these ideas percolating and bubbling up, and we got to focus on some of them. So one of the things that we like to do with younger learners is to use addition charts, not as a retrieval device to retrieve addition facts, but more as a pattern finding device where kids can look at that addition chart and go, like I'm noticing that there's tens here. Well, there's a pattern where if I add these numbers together, like check it out, in this diagonal they all add to 10. In this horizontal they all add to 10. What was happening? It's all these numbers plus, or sorry, not add to 10, add to the number. It's like the numbers repeat. Well, it's because I was adding 0. Ooh, they're all one more. Ooh, it's because I was adding 1. Like there's these patterns that can come out of the addition chart that can be super helpful. We can also analyze strategies. So if we want to build foundations for strategies, one of the things that we can do is look at student work where we've smudged out part of their work. So for example, if I've got a student who's adding 7 plus 3 on a number line, and they've got a jump to 7 and then a jump of 3 more to 10, but I smudge out how long the jump was and where they landed, just enough. I have to be careful. There has to be enough information on there that the kids can fill in the other parts. Then I can say, how did this student use that strategy? Let me give you maybe a better one. What if I had a student doing something like 15 minus 5 and then minus 2 more? And again, I've smudged a little bit of that, but when the kid fills everything in, they can go, okay, I can see what the student was doing 15 minus 7, but they did minus 5 first and then 2 more. Then another student, or maybe the same student, did a different problem, 13 minus 3, and then they subtracted 4 more. And then another student did 17 minus 7, and then they subtracted 1 more. And the point that we would want to be pulling out is, what did the student do every time? They subtracted to 10. They removed to 10, and then they removed the extra. Oh, that's one of the major strategies. So by smudging out part of the work and having students fill in the smudges, and then asking them to kind of like take a bird's eye view and what was the student doing every time, bam, we start to develop the foundations for that student to own the strategy of removing to 10. So that's an idea that we can do. We can also do things where once they've kind of started building those relationships towards those major strategies, create anchor charts that make those relationships visible. So we might have an anchor chart that says, what are the subtraction strategies we've been looking at? Well, one of them would be remove to 10. And we could write remove to 10 and have an example on a number line. And then we've been using doubles, and we could put that on there. And we could say we've removed a bit too much, like remove 10 and adjust. An example of that would be 17 minus 9. I could say, well, I'm going to do 17 minus 10 because I know what that is. Oh, but I only meant to subtract 9, so I have to adjust up. So kids can look. We can anchor those strategies and put them on the wall, and kids can use those in their work when they're doing other tasks. Kim, you mentioned one other category, which is we believe kids need to do some practice. But boy, our practice might look a little different than some of the practice that we maybe experienced as students. One of the things that we can do for practice are things like we've talked about in another episode, so we'll put this in the show notes, where we can create hint cards for kids. where you interview kids, facts you know, facts you don't know yet. And the facts that you don't know yet, let's just focus on that smaller set of facts. But as we're going to flashcard kids with those facts, on that flashcard, we're going to call it a hint card. Let's create a hint that would be helpful to you. Just a hint, not too much. Don't give it away. Don't make it too crazy to read, but don't make it too hard that it doesn't help me either. And write your personalized hint on that card. Bam, we want kids to actually practice those. And there's some other things that we could do to practice, including games. It would be super helpful for kids. And we want to sort of sequence these messy tasks with strategy focused tasks, with practice tasks, and rinse and repeat.
Yeah. So, when you are creating sequences for your students, you might want to consider, what is it something that I can do that's kind of messier with my kids, and then strategy focused, and then practice. And we've listed several ideas here, but you could be thinking about, what do my kids need? What are the foundations that we're working with? And what could I string together that would help nudge kids along based on what I know I can do?
Nicely said. And if you're interested in a sequence kind of like we just described, we've actually planned that out for you in an easy to read format in a project that we've been doing with Hand to Mind called Foundations for Strategies. There's an addition subtraction for young learners, addition subtraction for single digit numbers that you could check out. Hand to Mind Foundations for Strategies. We'll put that link in the show notes where you can just do the sequence that we've sort of suggested with all the helps and teacher notes. But since it's Hand to Mind, it's super easy to read. All right, Kim, thanks for chatting about sequencing younger tasks. Let's sequence some older tasks to come, yeah?
Yeah, sounds great.
All right, in our next episode. Y'all, thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com and keep spreading the word that math is figureoutable. Hey, listeners, don't forget, go to mathisfigureoutable.com/book-launch to register for the free Developing Mathematical Reasoning, Avoiding the Trap of Algorithms book launch webinar taking place on March 18th. Y'all, I'm going to be there. It's going to be cool. You do not want to miss this. Totally free. Come join us. mathisfigureoutable.com/book-launch. We'll see you there.